All right, so we're going to look in more detail at graphing rational functions. And we've seen this a little bit, but now we're going to get really specific and detailed with it. So all of the polynomials we've been sketching, especially in lesson 16, those are continuous functions. Rational expressions are not continuous. Instead, they have areas where we have to lift our pencil to draw them. And either we're lifting our pencil because of an asymptote, or we're lifting our pencil because the function jumps over a certain spot. So let's see what this looks like. So we've got our first type of discontinuity, which is asymptotic. So asymptotes, there's two types. A vertical asymptote happens when my denominator is equal to 0 and the numerator is not equal to 0. So asymptotes, vertical asymptotes, are because I divide by 0. And we've seen this a bunch. Horizontal asymptotes, well, a horizontal asymptote is what is happening as x is approaching infinity. So horizontal asymptotes, these happen for x approaching positive or negative infinity. Infinity. There we go. Make that a bit smaller. I can cross a horizontal asymptote. Nothing illegal is happening at a horizontal asymptote. A horizontal asymptote is representing a y value for a certain x, so I can cross them. A vertical asymptote represents dividing by 0, which I can never do, which is why we don't cross vertical asymptotes. So, if my power of my numerator, so this is my degree of the numerator, looking up here, I've got my degree of my numerator is n, degree of denominator is m. So if the degree of the numerator is less than the degree of the denominator, then y equals 0 is my horizontal asymptote. Sometimes I abbreviate this as HA. If my power of the numerator is equal to the power of the denominator, then the ratio of their leading coefficients is my horizontal asymptote. If the degree of the numerator is greater than the degree of the denominator, so if I have something like x cubed divided by x squared, well, this is dominating this, which means I'm not going to have a horizontal asymptote. So no horizontal asymptote in that case. So those are asymptotes. A discontinuity, a point discontinuity more specifically, is when the numerator and denominator are equal to 0. So this means that I would have something like this. X plus 2 times x plus 1 over, let's say, x plus 2 times x minus 3. In this case, these cancel out. So my graph will look like this function, x plus 1 over x minus 3. And in this situation, I could plug in -2. If I plug in -2, my y appears to have the value -1 over -5, so that's 1/5. But I know in the original, -2 1/5 is not really a point though. It's not a point on the original. So that makes a hole. That leads us to a hole, or more formally, a point discontinuity. And we'll see what that looks like when we sketch it in the next set of videos.